Hey everyone, doing another stream today. Today we're going to lock in, I hear myself talking, that's not so cool. Alright, sorry about that. We're going to do another stream. We're going to figure out how to lock in prize thresholds. So once you cross a certain level that you are guaranteed those prizes on close. We're going to figure that out. So let's get going.
What the fuck is this?
All right. So like I said, we're going to work on the thresholds today. How that works. Let's just switch to iPad for a second, I think. So when we're dealing with a threshold, we have a stack of prizes that they win of 5 different prizes. And this is a threshold. So index number 2 is a threshold. So if the user answers this one correct, then great. If they answer this one wrong, they get nothing because they haven't locked anything in. But if they answer this one correct, they get up to here. Now, if they answer this incorrect, they get nothing. If they answer this correct, then they're guaranteed these prizes, even if they answer this one wrong or this one wrong. These things get locked in. So we just need to figure out when we're finalizing a game, did they cross any thresholds? And I think that'll be kind of okay. So let's go back here. Here's where we kind of left off. We just built this finalizing game thing in the last episode where here's what it looks like. Yep, we're not running. We have a case where the user had won everything, a case where the user had won nothing, and a case where the user had won something in between but had like chosen to leave. So here they answer this correct, but they just chose to take it and run. So let's build another case where the user has answered the first one correct and the second one incorrect. So let's launch new game, show the question, start the game, second wrong. So we're going to show the question. Great, so we answered the first one correct. We're going to try the second one, and then we're going to answer it incorrectly. So before we click that, let's look at our code. So what we're trying to do is this thing right here. So here where we are in the controller, this thing about finishing the game. So right now, what this is doing, this is where we're finalizing out a game. We're going through our prize stack, and for each thing in the prize, we check to see, is it correct? Like, did we answer the question, and is it correct? And if it is, we give them the prize. Now, this is kind of wrong, because if one of them is incorrect, if the top one's incorrect, they don't win anything. They only win what's in their threshold. So we need to kind of like revisit this. So we have 4 things in a prize, or 5 things in a prize stack at these intervals, or at these indexes. And this is a threshold. And so what we kind of need to do is we need to look at so we need to loop like from, let's see, from the top down or from the bottom up. If we're looking from the top down, from top for each, we would need to, if there's no asked, if we didn't ask that question, then we return prize. If there is an asked and it is correct, then claim prize, or we won the prize. If asked and incorrect, here's the case. Okay, so that we did ask a question and it's not, and they answered it incorrectly. So if they answered it incorrectly, they clearly did not win that prize. But we're now checking for thresholds. And so from that point, now we keep looping down. All right, so in this case, then we're going to say not asked, wrong, correct, correct, correct. So when it's 4, we didn't get it. Okay. When it's 3, it's not correct. So return prize. Then we continue down to the threshold. For the sake of argument, let's say that there is a 2.5 that they got correct. Just so I can make sure this logic works if we expand this list. So in the case of 3, it's not correct, so they return prize. And we mark has a like has failed is true. So now what we need to come back is, so when we're looking at this index, it is correct, but and not has failed. If asked and correct and has failed, so this one is correct, but they have failed and not a threshold, return. If it's asked and correct and they've failed, and the current one is a threshold, then we set has failed false and continue on down. So that way we're ticking from the top down, looking for what prizes to give them. And so once we cross over that threshold, has failed goes away, and then it's just, hey, correct, correct, whatever. I think that might work. Let's see if we can actually implement this. So the prize stack, right now we're going from the bottom up. We're just looping 0, 1, 2, 2, 3, etc. I don't think that's the way we want to go. Because then I have to backtrack. Then I have to get all the way up to 3 before I know that I have to go back 1 and check. So let's just invert that instead. Let's say game.prizeStack.reverse. Let's just flip it around and go for each prize index. And just so we know what it is, question index is going to be like the opposite of index. This index is going to count whatever, so this will be like 0. So we need to like flip that around. So it's really going to be like game.prizeStack.length. So 5 minus 1, 4 minus IDX. So this is always going to be 5, and then it will be, or no, that'll always be 4, and then we'll start at 4, then 3, 2, 1, 0. Okay, yeah, so that should be right. So this will be like the index in the correct order. So now we're going to look to see, did we ask the question at that index? And if we did not even ask the question, then we can release the prize. Else, if we ask the question and question asked dot is correct is false, if is correct is false, they answered it wrong. If they answered it wrong, they never win the prize. Else if, okay. Then else if, so now we've covered this case and we covered this case. But now we also need let has failed question that is now true. I need to put that outside the game's this loop. So outside the loop, so once we get through here, we've set it, we've flipped it around. And so now we can use that. So now, if question dot is correct, and we've not has failed question, win prize. Else if question to ask dot is correct and has failed. So if the question has been that we're looking at is correct, but they failed the question already, then is this prize a threshold. Then we release it. This is finally the first part of this whole app that I kind of want to test for. Well, let's see if I can do that. I mean, there's a test setup here. New file. What's this? Game controller.test.tsx. Let's just see if we can even get this thing to run, huh? I'm not really even testing Preact. So clearly the dev target doesn't actually test this thing. That's fun. npm run jest, I guess. Oh, test. Hey, there we go. I mean, it runs, I guess. We just gotta manually do it, I guess. And if we fix it, do the test pass. Cool. All right. Let's split this then, and let's figure out how to write a test. I don't think the finished game call is going to actually persist something. So I think I want to abstract this out to some other method that's just like simple inputs and outputs so that it is easy to test. So what does that look like? I guess I want to say get prizes 1, and we'll take a game. And it should return an array of prizes. So we're going to test get prizes 1. It returns an array. Game controller. I guess let game equals new game. how do we pull in that guy? When we had this, how were you pulling that in? I guess you just referenced it like that. That's fine, I guess. So we're going to import game and game controller from source.controllers./game controller. Cannot find module source controllers. Why not? Up from tests into source. Oh, I think I'm supposed to go up twice. There we go. All right, so game is going to have an ID that is a test game. Game controller as game. Player name test. Is finished false. Prize is 1 empty. Question asked empty for now. Started on date time dot now. Prize stack. All right, so we have our game and we are testing the function get prize is 1, and we're going to pass in our game, and we're going to expect that to be an array. To be cool. To match an object that's an empty array. Cool. All right, so let's start implementing our logic here from finish game. So it returns no prizes for no correct answers. Let's build a little helper function. let game equals get test game. And what? We need to populate some stuff into him. So game dot question asked is going to be a new array, and we are going to put some things in U, like what? Question index and question ID. Question index 0, question ID 1, 2, 3, 4, answer ID 1 is correct, false. So we had one question and we answered it incorrectly. So that works, even if it works naively so. So that's fine. We'll actually do a little test-driven development, I guess. Returns prize for one correct answer. So we answer one question correctly, and then we bail. So if we do this, and we answer our question, and we say true, and then we leave, we should have a prize, but we need to get a list of prizes in here, which I suppose everything is going to have a prize ID. What does a prize look like again? Nope, I have two difficulty ones prizes. Is that right? How do my prizes map out? 0, 1, 2, 2, 3. Sure. Test prize 0 at difficulty 0, 1 at test prize 1, then 2, 2, 3. Okay, so now we have a list of prizes. That's cool. So now we get one correct answer, and we expect this to be an array with one thing in it. Like they should have won a prize. They should have won prize 0, right? And it wasn't, because we got an array, an empty array still. So let's start taking some of our logic here. We implement just as much as we need. All right, so we're going to go through our prize stack, whatever. We're going to get the question asked. If the question wasn't asked, we're not going to do any of the releasing of prizes. We are just going to let result is whatever, is a list of prize. And at the end, we're going to return result. So we're only figuring out if they won something. So game.prize stack. I guess in this case we could do game.questionsasked.forEach. And if there is a question asked and it was correct, then result.push game.prize stack at that index. Should be enough to pass that test. But it wasn't, because now we got undefined apparently, which I'm not sure how that's possible. Returns prize for no correct answers, that's fine. Why would that be undefined? We are creating it right there. Interesting. If I don't do anything there at all, it should still return. It does return an empty array. Okay. That's what I screwed up. Okay. All of these things are in prizes 1 when they should be in the prize stack. I set up bad data. Better. Cool. So we got one thing, prizes 1, there was one thing in it, we won prize 0. Cool. So now let's just say all correct answers. Let's just take the case where we answer. So we answered nothing correct, we answered 1 correct and bailed. For all correct answers, question index 1, question index 2, question index 3, and question index 4. So we asked all 4 questions, and I expect to get back, or all 5 questions, and I expect to get back a thing that says, hey, we are going to win all 5 prizes. And that works. Good. Okay. So now we'll build a case where for second question incorrect. So the user will answer the first one correct and then the second one incorrect. So correct and then incorrect, and then I would expect them to win nothing because they did not cross any thresholds. All right, and that's not true because right now it would still give them the correct, or the prize for the correct answer that they got. So now we need to introduce that concept of let has failed a question is false. And so we're going through here, and if we loop through here, but if it's not correct, in fact, it's not if it's just not correct, it's QA.isCorrect is false. So not like is correct just wasn't set. It was set explicitly to false. Then has failed question is true. And that would also just mean that like we should be done. Like we should just return out empty. Like right now we're not thinking about thresholds at all. We're just going to return. And anything that's in result yet, we would empty. So we're just going to zero it out. I don't even really need this concept yet. Let's just comment it out. Okay. Yeah, so if we encounter any of them that the user answered explicitly incorrectly, then then great. Okay, so it returns prizes, no prizes for third incorrect question incorrect. So now we get posed 3 questions. The third one is incorrect, and this should just work, I believe. Good. So now the next case, it returns threshold prizes for fourth question incorrect. So this question 3, true, and is threshold. I would expect that to be, we're going to get back prize 1, prize 2, and prize 3. Or no. Yeah, 0 based. We get prize that. And that I expect will fail right now. Yep. We need to set that this prize right here is a threshold, which is what it should be in the data. And so how do we handle that? So now as we're looping through, we could still go from the bottom up if we, rather than zeroing it out, we know that we can so if we have the result, and maybe let's call it, we create another thing called a batch. Prizes within a threshold. So if we are if it's correct, we're going to add it to the batch. And if it was correct, if the question asked, let's just get the prize right here. If ask.is correct, then we're going to add it to the batch. And if the prize is a threshold, we're going to take result result.push.apply result batch. So that weird sequence is basically going to take all of the things in batch and stick them on result. It's like a weird way of doing union. because it doesn't have a native one. And then we are going to say batch.length is 0. So if it was correct, we take it, put it on the batch, and then if the batch is done, because we hit this threshold, we'll take everything and shove it on the result. Else, if ask.isCorrect is false, then we're going to take and just zero out the batch. But we'll never zero out the result. Oop, that did not work. Oh, well, some of them worked. All right, so if we never cross a threshold, like we do for one correct answer and quit, or if we one correct answer and then quit, we never cross a threshold. So if we never cross a threshold, when we're all done, we need to do this again. There we go. There we go. All right, I think that's all of the use cases here. Let's do one more test for they answered the 5th question incorrect. Just so we cover like everything. So that one was true, and then we're going to ask them a 5th question, and that one's incorrect, and it should be the same. They win the first 3 things. Nice. All right, so now we built this little function here, but we're not using it. Right now we're still doing a big old complicated thing around this. So we're not going to be able to test that stuff necessarily, but what we could do here at this point is say let prizes1 equal this dot get prizes1 for the game. And now we can go over the prize stack dot for each prize. And we can say let has1 equal prizes1 dot index of dot index of, because it should be the same thing. Although, let's just do a find. All right, so if there's some prize 1 that matches this prize, then we've won it. And that's great. We don't have to do anything else. If we didn't win it, then we need to release this prize so that somebody else can win it. And that's it. That's a lot simpler. Now we can just say game.prize1 is that. And that's it. Then this all gets deleted. So when we finish the game, we get the prizes that were won. We release the ones that weren't won. We mark the game as finished and save it. I like it. Okay. Now, the data that I have here in these games is no longer good because I changed all that logic. And I'm in test mode. So let's run this again and play some games. So clear some games. Lose, wrong 0. Play the game. Show me the question. Show me the answers. Let's answer it wrong. No prizes won. We won nothing at all. Cool. We have wrong 0 done. So let's find another player, show a question, start a game. Let's say wrong on 1. Show the question. Let's answer this one correctly. So this should be goodbye world. We won. Next. Let's show the question. We're going to answer this one wrong. And we finish. No prizes won, which should be correct because although that shouldn't be highlighted. That should not be highlighted. So let's figure out why that's highlighted. When we are on routes, game details, and we are rendering this, and we are rendering our prize stack, we are saying the largest prize index won. And we're just calculating that. Ooh, and that's incorrect. That should probably go elsewhere. And that logic should change. And why not? I mean, we have the ability to write a test for it, so let's do that. And work out those things rather than in the UI. So let's switch this thing back to jest. And let's write another function. We're going to describe something called get, I guess, largest prize index will be the name of the function. And what will it do? It returns -1 for no correct answers. So we'll get a test game. We will pose the user one question. We will answer it false. We will say, hey, give me the largest prize index. And we expect that to be -1. And obviously that doesn't work because we haven't implemented that function. game, and it's going to release a number and return -1. We'll make our test pass. It returns 0 for 1 correct answer. So if they answer the first one correct and then quit, that's what it'll be. Which obviously we did not build that. So I think what we could do is reuse this logic in one place or another. So essentially it's the same thing we need to do in both places. Here we're actually moving prize objects around, but we could just figure out what the number is and then and then move them accordingly. So if I actually just lifted all of this logic just for the sake of argument, and I said by default result equals -1. And we go through each of these questions, and we actually need the prize tag because we need to know if it's a threshold. If the answer is correct, it's being that we do need prizes to figure this out, the largest prize index is kind of state.game.prize1 .length -1. Maybe I don't need a function here after all. Let's switch over. There. Okay, I like that. I like that a lot. Okay, so now we have this one list games. So wrong 1, wrong 0. They both have no prizes won. If we wrong 2, it should still show no prizes won. So we need to answer this one correctly. So this is legit to quit. Final answer. Next question. Show me the question. JavaScript, the trademark is owned by Oracle. Next question. And if this one, we will answer it incorrectly. No prizes won. Cool. So now if we go one more and answer this one incorrect, we should win these three things. Okay, so now I've crossed that threshold. So now I'm going to answer this one incorrect. Finish the game. And we still won 3 prizes. Love it. I'd say we got this working. All right, let's clean up. Let's figure out what we need to do. All right, so we got rid of this. We're not going to implement that. If that's okay. The game controller itself, we changed around finish game to be quite a bit simpler, I think, and we implemented this get prizes 1, which is smarter. This got smarter, easier. The header test that didn't work anyway got thrown away, and now we have some tests around game controller. I love it. Prize thresholds and tests. All right, let's do one more little one. So we want to show the prize for the next question. So that's a little fun thing. So if we go back here and let's start a game, show prize. Right here, I want to do a big thing where I show the prize that the user could win if they do it. So like right here. And it should be just like what we did on the game finalization page. It should be pretty much the same thing. So on game details where we do that, here is where we're doing that. Prizes 1. So if we lift that out and go towards our render pre-question, we can drop prize to win is what I'm going to call the class on it. And what? And I need to figure out what the prize is going to be. There's not going to be that case at all. Let prize equals state.game.prize stack at state.questionIndex. And we will just populate prize right there. We're not going to be doing any sort of looping. In fact, I don't think I need, I think I could just, I think I can ditch that and just have you. Yeah. So now we just need to, prize to win is going to have a width of 80 view width, and it's going to be position absolute, and it's going to have a top of 180 pixel, a top of 40 view height, 30 view height, sure. And it's going to go left minus 20 view width. Oop, too much. Minus 10, minus 5. Minus 1. That looks pretty good. Prize to win on question details. Question details. Prize to win. Cool. Cool. All right, I think that's it. Show prizes for the next question. Sweet. Lifelines is what I have next. Show prize for next question. Nice. So Lifelines. I mean, we're kind of on a roll. How long have we gone here? A little over an hour. Let's take a start at Lifelines. iPad. Okay. Here's how Lifelines work. So we have a lifeline. How it works in the game is that in the real game show, you get 3 lifelines of 3 different types. There's like, you can use them at any time during the game, and there's like 50-50, which will eliminate half the bad answers. There's phone a friend or poll the audience. Now, I only have 5 questions, so offering 3 lifelines is a little severe. And implementing 3 different kinds of lifelines sounds kind of hard. I don't know that I have time for it. So I think what I'm going to do is give the player 1 or 2 lifelines. I'm not sure yet. 1 or 2, but they're going to be of the same type. And it's going to be ask a speaker. And what I mean by that is that, like, we're at a conference. There's conference speakers. I'm going to solicit some of them to basically be on a panel or whatever. They'll have a mic, and if the user wants, they can ask them. And it also gives me an opportunity for like some fun banter with, you know, other people. Kind of livens up the show. So I think that'll be fun. In the UI for this, so it only is going to really show up when we are in the pre-question and in the question is where we're going to show this. And in the pre-question, there basically has the stack, and here's the prize. And I basically just want to show it right there. Like, there'll be a button or maybe 2 buttons if I end up doing 2 lifelines. In the question itself, there'll be the question displayed here, and I'm going to just put them right here. When they are hit, when they use them, what happens? Do I want to like have some sort of fanfare about how that works, or do I just want to deactivate them? I mean, I'll probably play a sound. And what else? Would I want some kind of visual? Like, do I want to do like some sort of pop-up that says Lifeline or ask a speaker or like ask a speaker Lifeline? Ooh, it would be kind of cool to have a thing where if here's the UI, I have a bar that fires across, so like an animation, And this just says, ask a speaker with the same kind of whatever graphic this ends up being, and a close, just so I have like a thing to jump out. I like that. Let's do that. So I need probably a component for this, and that's like Lifelines, and the Lifeline will have I'll probably store it on the game, so they'll probably just want to take, hey, show me the lifelines for this game. And is clickable, because if it's in this case, I don't want to be able to accidentally click them. And that's it, because that lifeline should handle this thing as well. So I like that. I think both of those are doable things. So let's switch back to my code and figure out how to do that. So let's create a component called Lifelines. That'd be 2 words, I guess. Lifelines, yeah, probably. And let's just like lift one as a starting point. Pausing for a second. Lifeline, sorry about that. I am the lifeline. So we have that component, and now on our routes, routes question details, let's see, what are we at right now? We're on the pre thing. So we want to show it here. Div class lifeline wrap lifelines. And that should be kind of enough to show I am the lifelines. Cool. So now we want to render 2 button-like things, and figure out where they go. So here in that, we, I guess I want this thing to be a flex box, and I guess we could just make it a couple of buttons, just like literally buttons. Where are we going to store this? Let's think about that for a second. So here on the game, when a game is started, do I just want to like encode that ask a speaker is the only kind of lifeline? I think that's probably fine. If I want to implement more kinds of lifelines in the future, I can make this more complicated. So I think I just want this to be lifelines and make it a number, or here's how many you have. And then when we're setting it up, let's give them 2. I might roll that back to 1. 2, yeah, 2 is too many. Just 1. With 5 questions, like 2 of them allows them to basically ask questions for both of the hard questions which could be kind of boring. Let's leave this as a thing that can change, but hey Daniel. So this thing is going to take some properties now. So export interface Lifeline lines properties props, and we're going to take a game object. And what we are going to do is say, we're going to create a loop here, and we're going to say, so on props.game dot, no, we're just going to do a straight up for loop, I guess. For let index equal 0 while index is less than or equal to props.game.lifelines idx plus plus. Do you not let me do that? I guess I have to do that outside of here, huh? No, there's got to be a way to do that. How do we do that? React for loop. That's clever. Fine, I like it. Props.game.lifelines. So we're going to create an empty array of however length this is. So it'll be 0, 1, or 2, and we're going to fill it up with nulls, and then we're going to map whatever onto this. And it doesn't really matter what it is because it doesn't really matter. All right, so now we should have a button that says to do. Or we have an error. Because we already started this game before we redefined what this was. So that's fine. Let's go start a new game. Lifelines. Cannot read properties. Are we not passing that in yet? Probably not. Question details. Yep, there we go. Game. State.game. Okay. So I'm going to have 1 or 2 lifelines. This is just terribly clever. All right, I think we're actually just going to wrap it up right there. Running out of time for right now. We'll come back and figure out the rest of the lifelines next time.